Alright, welcome to Unit 6, Lines and Triangles. This is Day 2, Perpendiculars and Distances. What we're going to be doing today is we're going to be finding some distances. When you're finding the distance from a point, such as point P, to a line L, you'll always want the shortest distance, and that will always be a perpendicular. So I'm going to go ahead and make a perpendicular, essentially construct one, but I'm going to do so using slopes. So first thing I'm going to consider is the slope of line L. The slope of line L, if I use y2 minus y1, negative 6 minus 3, over x2 minus x1, 4 minus negative 5, I get a slope of negative 9 over 9, which is negative 1. Now, I'm going to consider the perpendicular slope, which will actually be positive 1 over 1. Remember that perpendicular slopes are always negative reciprocals. So since the slope here was negative 1 over 1, if I change the sign and flip it, it's going to be positive 1 over 1. That's the slope I'm going to use from point P to connect to line L. So I'm going to go up 1 over 1, and I'll continue it this way as well. Unfortunately, it hits directly on the line. If it didn't, that becomes a little bit of a headache. So connecting P into line L, there we go. That's my perpendicular. And what I'm now going to do is I'm going to figure out the length of that segment. I'm going to get rid of this first dot that I used. Okay. Now, we are going to find the length from negative 2, 0 up to 2, 4. You could use distance formula, you can use special right triangles, although we haven't gone over those yet. You could use Pythagorean theorem. You could make a right triangle here and do 4 squared plus 4 squared equals c squared and solve for c, which is what distance formula is. You know what, I'm going to do it that way. So you can use distance formula, but I'm just going to make a right triangle and use Pythagorean theorem really quick to solve for my distance. So 4 squared plus 4 squared equals c squared. And I'm going to get an exact answer here, please. So that's going to be 32 equals c squared. Well, plus or minus the root on both sides. I'm actually only interested in the positive root. And the reason is because this distance is going to be positive. And that does simplify because 16 goes into 32 twice. That's my biggest perfect square, so c is equal to 4 root 2 units. So 4 root 2 is how far point P is from line L. So on this new problem, we're going to be actually graphing the line, plotting the point, and if you want to go ahead and take a moment to do that, we'll be calculating the distance between the point and the line. And you can see I've already got that plotted out now. Now where I'm going to start is actually using the slope of the line. So the slope of the original line was 2, right here. And so now the slope I'm going to use when I find the distance between the point and the line is going to be the perpendicular slope. So since it's positive 2 over 1 that is, it'll be negative 1/2 is the slope that I'll use. So going from my point, I will go down 1 unit to the right 2 and do that again. And this one's not going to be as pleasant. This one actually does not hit exactly. So we're going to have a little bit of work to do here. Let me go ahead and get graphed out. It doesn't actually hit right on an integer point. So we're actually going to have to do a little bit of work to figure out what point this is right here. Honestly, what I'm going to do is just use a graphing calculator to calculate the intersection here. I already have the equation of this one to throw in my calculator. It was given to me when I was graphing. For this one, I'm going to write the equation for it really quick, and that's y equals, and that's going to be negative 1/2 x. Why? Because the slope was negative 1/2. And my y-intercept is 3.5, because it's going down 1/2 every 1 unit. So negative 1/2 x plus 3.5. I'm going to throw that in y equals as well. Alright, you can see I've already gone to y equals. I'm going to throw in the 2x minus 5. And I'm going to throw in the new equation that I came up with, the negative 1/2 x plus 3.5 was what it was. and I'll see where those two lines intersect. To do that, I'm going to first of all go to Zoom Standard, and I will see the intersection occur right in here somewhere. And then I'm going to use second calculate, second trace key. I'm going to select intersect. I want to know where these curves intersect. I'm going to hit enter for my first curve, the blue one, enter for my second curve, the red one. And when I hit enter one more time for it to guess, it gives me 3.4, 1.8. So now I'm going to put that on my graph. You can now see that I've included the coordinate 3.4, 1.8, where these two lines actually do intersect. I need to find the distance between that point and the original point, negative 1, 4. To do that, I'll use distance formula on this one. You could still use Pythagorean theorem if you like. The distance formula is the square root of x1 minus x2 squared plus y1 minus y2 squared. Again, taking the square root of all of that. So now I'm going to insert my values. So I'm going to have negative 1 minus 3.4 squared underneath the root already, plus 4 minus 1.8 squared. And what this is actually representing, this is actually representing Pythagorean theorem if you've never seen it. Let's go ahead and calculate the distance now, simplifying this stuff down. So I've got negative 4.4 squared plus I have 2.2 being squared. Alright, moving right along. I want to simplify that radicand a little bit. So when I square negative 4.4, I get 19.36 positive. When I square 2.2, I get 4.84. And when I add those two together, I get 24.2. And you know what? I'm going to convert that to an improper fraction of 121 over 5. And now I'll simplify that root. Remember, I wanted an exact answer. So it's telling me the square root of 24.2 is not an exact answer. It's not a good answer. Now I can use the improper fraction. I can simplify the numerator and denominator. So the square root of 121, that's actually kind of easy. That's 11. And the square root of 5 I cannot do. But I can simplify this now, rationalizing the denominator by multiplying by root 5 on top and bottom, because I'm multiplying by 1. So now, as a final answer for my distance, I have 11 root 5 over 5. Now, if the problem had told me to round, back here when I had the square root of 24.2, I would have thrown that in the calculator and said about 4.9, and I'd have been done. But the problem didn't say to round, it said to determine the distance, so I'm assuming it's talking about an exact distance. So now I have 11 root 5 over 5 units. Just so you know, this problem was a shade more difficult because it didn't intersect on an integer point. On my quizzes and tests, it's going to happen where it's going to line up on a point. Okay? Not really going to see this happen. I just wanted you to be aware of what to do in case it does. Alright, now for the last problem that I'm going to show in this video, finding distances between parallel lines. What's going to happen here is we're actually going to have these two parallel lines. We're going to find the distance between them because they never get any closer or further away from each other. So how do you start this kind of problem? Well, go ahead and pick a random point on one of the two lines. And now connect it to the other line using a perpendicular. Alright, so since the slope here is 2, my perpendicular slope that I'm going to use here will be negative 1/2. So going down 1 and to the right 2. And when you know it, they don't line up again. So I need to know what point of intersection that is, and then I can roll from there. With this first point being 0, 1. Now, for that purple line I just created, I'm going to go ahead and write down the equation. It is y equals -1/2 x, again I knew my slope, plus 1, because that was the y-intercept. So it's always kind of convenient if you pick a y-intercept to begin with on either of the two lines. Now I need to throw that into y equals. I'm also going to throw y equals 2x minus 3 in here, this other line that it's connecting to find their intersection. So y equals 2x minus 3 and y equals -1/2 x plus 1. You can see where I've gone ahead and thrown in those two equations. And now I'm going to go ahead and go to the graph. I'm going to calculate the intersection again. Excuse me. Just waiting for it to get done with the graphing part. Second, calculate. Again, I'm going to select intersect, the fifth option down. Go ahead and hit enter 3 times. Tells me the intersection is 1.6.2. Alright, and I'm going to use that information now on my graph. So, redrawing quickly in my graph. I know that my distance is going to be from points 0, 1, that one I picked. And now I know this is 1.6.2. So now all I got to do is use some distance formula yet again. Distance will equal the square root of 0 minus 1.6 squared plus, now I get my y values, 1 minus 0.2 squared. And now I'm just going to simplify everything down as far as I possibly can. So whenever I square negative 1.6 right there, I'll get 2.56. And now I'm going to square the 0.8, and that's going to be 0.64. So I have the square root of 3.2. Now, if it said that rounding was alright, if it said approximate distance, I would just square root that there and get 1.8 units approximately. However, it didn't say that, so we're going to do the same tactic as earlier, where I'm actually going to convert that to an improper fraction of 16/5. This one's actually just as easy as the other one. So the distance will equal 4 over the square root of 5. And again, I'm going to have to multiply by the square root of 5 to rationalize the denominator. So my final answer here will be 4 root 5 over 5 units. Again, tougher problem than what you're going to see on a quiz or test for me, but they're definitely out there. You live in a world where things just don't always line up beautifully, so you sometimes have answers that are going to be like this. So it's all right. It's what we get. Again, the approximate distance is 1.8 units, but now we know it exactly. All right, appreciate you tuning in. Definitely ask me questions if you got any. There is one more problem on the notes that you can look at as practice and talk to me about. Also, do the assignment. Appreciate it.